Assalamualaikum warahmatullahi wabarakatuh and a very good morning to everyone. Today we would like to conduct an experiment related to laminar flow and turbulent flow. But before we started our experiment, I would like to introduce our member group, which is NURUL FAQIHAH, ALWANI FALIHAH, NURUL NASUHA, and also NURHUNSA LIYANA.
This experiment by filling a plastic bag with water and then poking it with a knife. So the main objective here is to observe how the water flow through a small opening and to differentiate whether it's laminar flow or turbulent flow.
Before we are going too far, I would like to explain a little bit what is laminar flow and turbulent flow. Laminar flow, also known as streamline flow, occurs when a fluid moves in smooth and parallel layers without mixing. The motion is calm and orderly with particles moving side by side at low speed. It usually happens in a small or narrow passage where the flow remains steady and gentle. The shear stress in laminar flow mainly depends on the fluid's viscosity and not affected much by its density. Is turbulent flow. Turbulent flow is the opposite of laminar flow and occurs when a fluid moves quickly and unevenly. The speed and direction of the fluid constantly change, creating irregular and chaotic motion. This type of flow usually happens at high flow rates or in a large pipe where the fluid moves very fast. In a turbulent flow, swirling motion causes eddies and wakes form, making the movement unpredictable. The shear stress in turbulent flow depends mainly on the fluid's density rather than its viscosity.
The purpose of this experiment is to demonstrate the concept of laminar and turbulent flow using a simple setup. We wanted to observe how changes in flow speed and pressure affect the behavior of fluid, similar to what happens in pipes or fluid systems. We use a plastic bag filled with water to demonstrate the concept of laminar and turbulent flow. We carefully poke small hole in the plastic bag using a knife or sharp object and observe how the water flow out from the holes. This experiment also to understand fluid behavior to see how velocity and pressure change can turn a smooth flow into a turbulent one. And also it's applied theory to real life. This helps us relate classroom concept of Reynolds number and flow pattern to a simple visual experiment. And also demonstrate flow control, similar to how flow in pipes, food processing lines, or liquid packaging can change with speed and pipe diameter.
Next, I'm going to explain about concept of fluid flow. Fluid flow refers to the movement of liquids or gases from another location to another, typically driven by difference in pressure, height, or energy. The behavior of fluid in motion is influenced by several factors, including its velocity, viscosity, density, and the shape or dimension of the pipe, channel, or surface it passes through. Fluid flow can occur in different forms such as laminar, turbulent, and transitional depending on these conditions. Overall, fluids can move in various directions and may exhibit steady, uniform motion or irregular, chaotic behavior reflecting the dynamic and complex nature of fluid movement.
Explain the concept of laminar flow and how it relates with our experiments. So in fluid mechanics, laminar flow means the liquid moves smoothly and move parallel without mixing between layers. So the movement is very calm, steady, and very organized. In our experiment, when we poke the plastic bag that filled with water, we could see that the water comes out slowly through the holes, and then it is clear, straight and smooth. They show that it is laminar flow because the water moves gently and doesn't splashy and does not swirl around. Okay, now let us talk about the characteristic of laminar flow. Laminar flow is smooth and steady, and the velocity at every point stays constant over time. The water layers do not mix, and the streamlines are straight and parallel. This type of flow usually happens when the fluid moves slowly or when it passes through a narrow opening. So now let's talk about the Reynolds number. When the Reynolds number is below 2000, the flow is laminar, but when it is above 4000, the flow becomes turbulent. So in our experiment, when the water flows slowly through the small hole, the Reynolds number is small, which means it is laminar flow. But when the water comes out faster, the Reynolds number increases and the flow becomes turbulent.
Concept of turbulent flow. Turbulent flow occurs when the particles in the fluid start to move perpendicular to the dominant or mean flow direction and exhibit chaotic change in direction, flow velocity, and pressure. Laminar flow transition to turbulent flow when the inertial force created by the kinetic energy of the liquid or gas exceeds the viscous force of the fluid. Turbulent flow is chaotic and can be defined with a deterministic of equations. Instead, engineers use statistical methods to predict highly irregular behavior. So, how is turbulent flow calculated and characterized? The science of fluid mechanics use statistical method to characterize and predict fluid velocity, fluctuation, and pressure fluctuation caused by turbulent flow. This characterization starts with the dimensionless quantity called the Reynolds number. For the equation then capture up the behavior useful in designing or accounting for turbulent flow. So this is the Reynolds number formula. Re equal to flow velocity multiplied with characteristic dimension or characteristic length divided with kinematic viscosity and equal to density of the fluid multiplied with flow velocity multiplied with characteristic dimension or characteristic length and divided with dynamic viscosity of the fluid. So this is the importance of the characteristic of turbulent flow. The first one is fluctuation and eddies. An important measure of turbulent flow is fluctuation, which is the variation in velocity in magnitude and direction from the mean velocity magnitude and direction. When fluctuation exhibit a swirling, circular motion, they are called eddies. This variation in flow drives the velocity, vector pressure, and temperature of the fluid, as well as the kinetic energy and mixing in chemical reaction and the shear loss on structure. The second one is dissipation. The kinetic energy that creates turbulent flow is converted into internal energy through viscous shear stress. The energy in large eddies cascade into smaller eddies with more shear force and these cascade into even smaller eddies with increasing shear force. As the eddies get smaller, the kinetic energy dissipates as viscous energy. The third one is kinematic energy and viscous energy. The kinematic energy in turbulent flow is the amount of kinetic energy per unit volume, and it represents the average energy of the turbulent velocity fluctuation in the flow. The viscous force in the fluid converts some of the kinetic energy into heat due to internal friction. The amount of heat converted is called the viscous energy. The last one is mass, momentum, and energy transport. Any engineer or scientist working with fluid dynamics wants to know how mass, momentum, and energy transfer within the fluid flow they are studying. This is especially important in turbulent flow because it impacts the rate of all transfer behavior. This transport can also be referred to as turbulent diffusion. This is the importance of the laminar flow and turbulent flow in food industry. First one is heat emitting. In food factories, liquids like milk, sauce, or juice move through pipes. Turbulent flow means the liquid well so the heat spread evenly and useful for process like pasteurization. Laminar flow move smoothly with less mixing. It good for delicate product but not great for even heating. The second one is equipment design. So knowing whether the flow is laminar or turbulent helps engineer design pipes, pumps, and heat exchanger correctly. Turbulent flow needs stronger pump and use more energy, while laminar flow need less energy but may heat or mix unevenly. The third one is product type. Thick food like creams or honey usually flow laminarly because they're viscous and move slowly. Thin liquids like water or juice often flow turbulently because they move faster and mix easily. Understanding this helps make sure the product texture and quality stay consistent. The fourth one is hygiene and safety. In cleaning food equipment, turbulent flow helps cut surface and remove dirt or bacteria. But in processing, too much turbulence might spread bacteria if the system isn't clean. Laminar flow, especially of air in clean rooms, helps keeps areas sterile by preventing dust and germs from floating around. The last one is energy and cost. Laminar flow use less pumping power to save energy, while turbulent flow give better mixing and faster processing but cost more energy. So, the food industry must balance both. It's mean laminar flow for energy saving and turbulent flow for good product quality.
In conclusion, we learned that laminar flow occurs when fluid moves slowly and in parallel layers with minimal mixings. And however, turbulent flow happens when the velocity increases, causing irregular movement and mixings. Flow rate, hole size, and pressure determine the type of flow. This experiment helps us understand how controlling flow condition is important in industries such as food processing, where smooth flow ensure quality and consistency in product.